Hello everyone, this is Navin Kumar. T- Today my topic is about the analysis of aircraft structure. In that topic, my topic is about the measurement of shear flow in the thin pallid beams. As has the shear flow means the flowing of shears, as we all know that the shear flow means the flowing of shear stresses through the beam. Here my topic is about the measurement of flow shear flow in a thin walled beams, as it how the shear flow is measured. So the shear stresses which are flowing through the beam are measured. So for that, I have considered shear flow in the beams which are having x-axis, y-axis, and z-axis. The flow of shear flow, and here the flow of shear stresses in the z directions, and in the x directions and in the y direction, and uh, here sigma s is the direct stresses, and whereas sigma s is the shear stresses. By by resolving these shear flows, we can get that if the flow if the stresses are passing through the beams, and it will exit as a sigma s plus dou sigma s by dou s into sigma s, where del is the deflections of stresses, where are tau, and if we get out of these if we, the stresses are passing through the beams, it will exist as a tau sz plus and dou sz by dou s into dou s, whereas it comes through the in the directions, the say stresses exhibits as sigma z plus dou sigma z by dou z and delta z, and it will, whenever it passes through in the y direction, so the sigma or sigmas are coming as sigma y by sigma y plus dou sigma y by dou y into dou z. And here the general shear system on the elemental closed section and direct shear flow of the elements. Here I have considered closed and open section, where how the shear flow get measured, and how the shear flow get measured. Yeah, the derivation which I am going to explain in shear flow of the beams by using these diagrams. And from the diagrams we can take you can if you take from horizontal and vertical axis, vertical and horizontal equilibriums, so the equation becomes like sigma z plus dou sigma z by dou z into delta z, and t into dou s by dou into dou s minus dou sigma z into t into dou s plus q into dou q by dou s into dou delta s into dou delta z minus q into dou delta z is equals to 0. And the equations which is equated to 0. And here the T is the thickness, where Q is the shear flow, whereas sigma Z is the direct stresses, and Z is the with respect to the plane axis. And here the negative sigma Z, because which are passing in anti-clockwise directions, anti-clockwise movements, and the shear flow in negative direction, which is acts which has which are outside this side. And the equation as uh, reduces to dq by ds plus t into d sigma z by dz. If you substitute this, if you cancel by canceling that by canceling these stresses, and the equation reduces to this equation, which is dq by ds plus t into d sigma z by dz is equals to 0. Similarly, for equilibrium in S direction. So here we have considered for the Z direction, and if we consider for the S direction, here sigma S plus dou sigma S by dou Z is equals to Ts into sigma S into Tz into dou Q by dou S as S direction. And by considering equilibrium in S direction, the equation becomes as this in stresses in S direction. And if you assume the direct stresses are obtained with sufficient accuracy from a basic bending theory, as we all know that the bending equation, which is of which is of sigma 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 of ix moment, uh, the bending moment equation for a symmetrical plane is my by z is equal z into y, where my is the moment along y-axis and z is the distance from the neutral axis, whereas I-axis is the moment of inertia about x-axis, xx, and dm by dz is of dou sigma z by dou z, and where xy is the x x ixy is the moment along xy direction, moment of inertia along xy direction into x. It is the distance from neutral axis. By considering same as in y direction, so the equation becomes as dou sigma z dou mx by dou z into Iyy minus dou my dou z into Ixy. So the equation as becomes Ixx into Iyy minus I square xy, whereas it becomes Ixx into Iyy into minus I square xy. If you substitute, if you substitute for dou m by dou m by dou z in terms of sx, sx is the moment along x direction. So the expression becomes as dou sigma z by dou z is equals to sx into ixx minus sy into xy divided by xxy ixx into I by y minus I square xy into x. Whereas it becomes sy if you substitute for a dou mx by dou z is equals to sy. So the equation becomes as sy into I by y minus sx into ixy divided by xx into Iyy minus I square xy into y. So the dou sigma z by dou z is above equation by substituting equation. So this equation becomes as dq by dou s is equals to sx into sy by sx into sy minus ixy into ixx into iyy minus I square xy into tx, and minus sy into iyy minus sxy into ixx into iyy minus I square xy into ty, where the is the thickness, x is the distance from the neutral axis, distance from the neutral axis, q is the shear flow, whereas s is with respect to s plane, s direction. Sx is the moment along moment along x direction, a shear moment, and these as we dou q by dou s is integrated, and the shear flow is by integrating that we can the equation becomes as the with integrating from 0 to s and dq by ds into ds, and is equals to minus because of shear flow is negative in that directions. So yeah, by taking common sx minus ixx minus sy into ixy by xx into iyy, so into t into tx into dx, and integrating for a y for a while same, it becomes as 0 to s into ty into ds. So the shear flow equation becomes as qs is equals to minus of sx into ixx minus sy into I by ixy into divided by ixx into iyy into I square xy. So the integration of these equations as tx into ty. So for as we all know that for a moment of inertia about ixy, if there is a center of symmetry along x direction and y direction, the equation should be considered. If you substitute 0 in this equation, here it will become 0, and this sy by xy will also become 0, and this I square xy is also become 0. Um, Sx into Ixy also becomes 0. So the equation becomes as Qs is equals to Sx by Iyy integral of 0 to S dx minus Sy of Ixx into integral of 0 to S into Ty by ds. And the arguments in the open section beeps and apply for the shear flow at a point of under the closed section and comprising of beam skin and direct stresses, TD is neglected. And if for a beams, the TD will become 0 if the skin is less. So the basic for open section, so it becomes TD becomes 0. And for For a shear flow of a beams for a open sections, it becomes as sxx sx into ixx minus sy into ixy by xx into iyy minus I square xy integral of tdx into tdx into dx plus sigma x into n of r is equals to summation of n to r is equals to 1 br into xr, where v is the boom area, r is x is the distance of from neutral axis. Thank you.